Okay, we've got three more calculator multiple choice problems. So first one says, for what value of c will this function have a relative minimum at x equals -1? So they're basically saying that -1 will be a critical value of our function. So we're going to start by first typing in our function, x squared plus, remember I can do alpha c divided by x. I like to use my c value. It's just easier to track if I type it in exactly like the problem. Then I go to F3, calculus, and choice 1 is differentiate. And I'll pull my function into the line, comma x to take the derivative with respect to x. And this is my derivative. Now I need to evaluate the derivative at -1, x equals -1. Because I know when I plug in x equals -1 that my derivative function will be equal to 0 since -1 is a critical value. So I plug in -1 and I have negative c minus 2. So what value of c will cause that expression to be 0? And the answer will be -2. So I can circle B here as my answer. Second problem, they want to know the slope of the line tangent to the graph at its inflection point. So I'm going to go ahead and do this graphically. And I'm going to choose to type in the graph of e to the square root of x plus 1. So I have to close my parentheses. There's my graph. I don't know my window, so I'm going to do a standard window here. I think I'll just do zoom 6 and see what happens with this graph. E to the square root of x plus 1. And it's supposed to have an inflection point. So I'm unable to really tell. It kind of looks a little concave down and then a little concave up. Perhaps what I can do is use F5 and scroll down to choice 8, which is inflection. And I'll type in my lower bound where I'm pretty confident the function's concave down. And then for the upper bound, I'll scroll way to the right where I'm pretty confident the function's concave up. So it's telling me that there is an inflection point at 0. That's nice and easy to deal with. So now I need to know the slope of the line tangent to the graph at its inflection point. It's basically saying, give me the derivative of this function at its point of inflection. I'm going to do this one using the graphing screen again, just to show you how you can. So if I go to y equals green diamond F1, let's go ahead and use second 8 for derivative. And I want the derivative of the function in y1. So I put y1, open paren, x, close paren, comma x. So y1 of x with respect to x. My Leibniz notation comes up, so I know I'm going to have the graph of the derivative function. So what I want to do is go up to the first line, and I'm going to hit F4 to uncheck it, because we don't want to see that one. Then let's look at the graph. So this is the derivative graph of e to the square root of x plus 1. Okay, it's taking its time graphing, but I see what I need. I need the value of this graph where x equals 0. So I'm going to do F5, choice 1 is value, and type in 0 for my x value, and my y value is 1.359, which, by the way, is e over 2. And I can confirm that by going into my home screen and let's say green diamond e to the x and then divide e over 2, green diamond enter, look at that, 1.359. So my answer here is e over 2.